Welcome to the educational research portion of www.happynumbers.org. Today's video is dealing with the concept of stem plots, or sometimes they're referred to as stem and leaf diagrams. And stem and leaf or stem plots are another way of graphically representing, in this case, quantitative data. In terms of prior knowledge, you should have a good understanding of the histograms video and the video dealing with levels of measurement. You should have viewed those two, and then stem plots will make a little more sense. However, if you're familiar with the concept, then just carry on. Okay, let's take a look at what a stem plot is and how to make one. Okay, I have some data here, and this is Best Actresses Oscar winners data in ascending order. So this is the ages of the best actresses who have won Oscars for a period of 32 years. I think it was from like 70 to, well, I'm not, yeah, 100 to 2000 something. But it's 32 years, and it's the best actress Oscar winners, and these are their ages. So you can see they are put in ascending order from the lowest to the highest. And if you're working with stem plots, you will want to arrange your data in that order. So we have, one was 21 when they won it, 25, several were 26, 29, 30, and so on. And we want a way of graphically representing this. And stem and leaf or stem plots is one way to do it. So, step one is to separate the data into a leaf, which is the digit that is most to the right. In this case, the leaf would be 1, and the leaf here would be 5, and the leaf on 26 would be 6. And I'll show you how that looks. And then you write the stem, which would be the number, not the leaf, in vertical column with a line. So it looks like this. So first thing, we separated it into a stem and a leaf. The stem is 20. This represents 20. This represents all the data that's 30. This represents 40s. This represents 50s, 60s, 70s, and 80s. So we have a certain amount of data that are in the 20s, a certain amount in the 30s, quite a bit in the 30s. Then we have some in the 40s, none in the 50s, one in the 60s, one in the 70s, one in the 80s. Okay, so that's the first step, to arrange it, the data like this, 20, 30, 40, 50, 60, 70, 80. And then we put each leaf, the leaf, remember, is the digit that is right on the right side, and we arrange the leaves in increasing order. Pardon me, that's my phone, but we'll just let that ring. So let's see what that looks like. So now, here's our leaves. So this is 21. This represents 21. This is 25. That represents the number 25 here. This would be 26. So we have 3 26s, and so we have 20. 1, 2, and 3, and then 29, and so on. And this is the 30s. This would be 30, 31, this would be 33, 33, 33, 33, 34, 34, 34, 35, 35, 35, 37, 38, and 39. And that represents all the data in the 30s. This is our 40s data. So we have 41, and here's our 41. We have 3 41s. So we have 41, 41, 41, 42, 43, 45, 49, 49. We have no 50s data, so we just have and it's blank. We have 1 in the 60s, which is 61, 64, and 80. So we have taken then the best actress Oscar winners and put it in what is called a stem plot, or stem and leaf. And interesting, if we rotate the stem and leaf, we actually get a histogram. And you can see that if we look at the distribution this way, distribution is skewed to the right. It's skewed to the right. Almost all of the values are in the 20s, 30s, and 40s, and very few couple of values here, which might even be outliers. So that's how we construct a stem and leaf. You may want to pause here for a minute, just take a look at this, review it in your head to see how it was done. Or you can, of course, go back and listen to it again. Now, we have an awful lot of data in the 30s here, and even in the 20s and in the 40s. So we can do this. When some of the stems hold a large number of leaves, we can split each stem into two. The first one holding the leaves from 0 to 4 and the others from 5 to 9. So this is exactly the same data, the Best Actress Award winners. But I have 20, this is 20, from 20 to 24, and this is 25 to 29. This is 30 to 34, this is 35 to 39, and so on. And so 21 is here, and then I have 25, 26, 26, and 29. And 30, which had an awful lot of data, I've split it into two. So this has all 30, 31, 33, 34, and then 35, 37, and so on. So if you have a large amount of leaves, this is the leaves, large amount of leaves, sometimes you then want to split the stems in two. When we're dealing with larger than two-digit numbers, the process is exactly the same. Here is some data which is just made up, but let's say these are blood pressure, people's blood pressures. So we have 112 and 118 and 120 and so on. So we separate the numbers into leaves. And the leaf is the digit that is on the right. So the leaf here is 2, the leaf here is 8, and so on. And the stem is everything else. So the stem here is 110, this is 120, this is 130, and 140. So we have 112, and that's our first data, piece of data, 112. This is 118, that's the next piece of data, right here. This is 120, our next piece. This 123, 123, 125, 129, which corresponds to our data here. Then this is the 130, so we have 130, 133, 133s, 134, 136, 140, 141, 143. So no matter how many data, how many digits are in the particular piece of data, the digit on the far right, pardon me, is your leaf, and all the other digits are your stem. And again, if we flip this over to histogram, we have sort of a histogram, and this looks like pretty symmetrical, with one peak. Excellent. Okay, and there's one other way we can represent this. Remember, we're dealing with quantitative data now. And that is called a dot plot. A dot plot. And it is very much like a stem plot. It shows every observation, but the observations are reported as dots. So this would be 21, this would be 25, and then 3 26s, and so on like that. Well, that's all. Fairly simple concept. Fairly simple concept. So that is stem plots, which are ways of graphically representing quantitative data. Thank you very much, and we'll see you next time.